Schmier shirts is an order up to problem. We'll start with part A, which is asking us to determine the average number of shirts on order. In other words, this is basically solving for the pipeline inventory, which is equal to the expected demand in one period times the lead time. In this problem, we know that the expected demand in one period, which is 1 day, is given to us as 1.5, and we know that the lead time for an order is 3 days. Therefore, the on order or the pipeline inventory is equal to 4.5. Moving on to part B. Now we're looking for the probability during any given day that Schmier's does not have sufficient inventory to meet the demand from all customers. In order to do this, we're trying to compute the probability that demand over the lead time plus 1 period would exceed 8. In order to convert the demand to 1 plus 1, or the lead time plus 1 periods, we'll take the daily demand and multiply it times our new n, which is the lead time of 3 plus 1 day. Therefore, demand over the L plus 1 periods is equal to 4 times the mean daily demand, which is 1.5, for an answer of 6. From the Poisson distribution function table, we're now looking for the probability that the demand is greater than 8. And in order to do that, we'll look up for the 1 minus the probability that for that Poisson function has an order up to quantity of 8 and a mean of 6. The corresponding probability, when you look up that function, is 0.84724. So that's the probability that demand is less. So the probability that demand would be greater than 8 is therefore equal to 1 minus that, or 0.15276. Moving on to part C. Here we're trying to evaluate an order up to level that yields at least a fill rate of 90%. We know that fill rate is equal to 1 minus the expected back orders over the expected demand in one period. We can rewrite that formula in terms of expected back orders, which are equal to expected demand times 1 minus the fill rate. We know a lot of those data points. So we know the expected demand in one period has a mean of 1.5 times 1 minus the target fill rate of 0.9. That's equal to 0.15. Now, using the Poisson loss function table with a mean of 6, since we know that's the mean in the lead time plus 1 period, we find that the probability of 0.15 falls between a loss function with of an order up to quantity of 9 and one that with an order quantity up to 10. So using the roundup rule, the order up to level should be S is equal to 10. Finally, for part D, in this case, our overage cost is given to us as 1 cent. That's the daily holding cost. Our underage cost, on the other hand, is given to us as $6, which is the cost of a stockout. Therefore, our critical ratio is equal to CU, or $6, over 6 plus 0.01. This is a probability of 0.9983. Expected demand over the lead time plus 1 periods is a Poisson with mean equal to 3 plus 1, or 4, times 1.5 is equal to 6. We saw that for that earlier. So then, from the Poisson distribution function table, looking for a mean of 6, we realize that the order up to quantity that corresponds to this 0.9983 is between 13 and 14. Thus, using the roundup rule, the order up to level should be S is equal to 14.